The X definition in the new version 4.2 for processing and converting of XML to JSON to XML, XML to YAML, YAML to XML, and we will present shortly the special form of recording of data, which we call XON, X-Definition Object Notation. I will start with something what some of you know, but I suppose that most of people, or not all people, do know what X-Definition is. So X-Definition is a programming language that was originally designed for processing of XML data. And it is open source now, available at this address. Each X-definition is written as an XML document. So it is a language which is written to the XML form. One X-definition can describe the structure of one or more models of data objects. And it is possible also to declare some methods, types, and variables. X-definition may contain a reference to another X-definition, so you can have the set of X-definition interlinked together. And collection of X-definitions is compiled to a Java class. It's a compiler. The X-definition starting with version 4.1 describes data models for JSON, YAML, properties, winning, and CSS. Now it's 4.2, sorry. Anyway, I must say something to this. X-definition 4.2 is not yet released, and X-definition, the last build of X-definition 4.1 supports all features which will be described here. So, X-definition 4.2 will be released in the next few days, weeks, months, years, I don't know. Now, to understand a little bit what we will speak about, it's necessary to recollect or to remind what is XML and what is JSON. XML data model in Java, for instance, is represented by document in the W3C document. And it's important to know that all values of attributes and text nodes, practically all values in XML, are just strings. So the actual work with any XML data requires knowledge of properties of values that are described in, for instance, in XML scheme or LaxNG or in X-definition. JSON data model is possible, is represented as Java map or Java lists. It means this way it are implemented instances of arrays or of maps or objects, how they call it in JSON. And the data, we call them primitive data, can be not only strings, but also numbers, Boolean values, or null. Properties of JSON data object can be described externally in JSON data or in X-definition. what to realize the project of XD definitions and JSON data, XML data, and some other formats of data, it requires the unambiguous transformation of both forms, of all those forms together, vice versa. It means XML to JSON and JSON to XML. And it must be unambiguous. And we can then define some kind of format which we can use internally for all those formats. So JSON map, the XML can be considered as JSON map with one named value. It is the name of attribute. It is a tag tag name of attribute of element, and then follows the this value is a JSON array, and the first item of this array is again JSON map, which describes the attributes of the element, and it can be, of course, missing if no attributes are present. And the following items in this array can be again elements transformed with this algorithm, or it means JSON maps, or JSON text values. So here we have simple example. Let's have XML describing some book which has title, date, and as you see, it can be more authors than one. So the JSON form will be book. Then the array, it is the named value of array, and there are attributes, title and the date. It is this first item of the array, and follows the elements which are the child elements of this element, author, those both authors. How to describe it in X definition? Those people who know already X definition knows. I just remind that in X definition we are describing the types and the occurrence of items by the special form of attribute. We call this language X script, and we can say occurrence. We can define occurrence of element, and this element has again the string. It is the X definition describing the element of book. And what we shall do with if it's data. So we need to put it into the special element which we call XD XON. We must say the name of the element because in JSON it can be map or array and so on. We don't know. We cannot simply know the name of to which we will refer from other X definitions, or to say what is the root definition. So the name will be book. We make it with oh, it's again the error. It should be XD root. It should be small letter, not big letter. And in this element, we simply put the JSON. And in this JSON, all values, we replace the same way like we did in XML. Anyway, we need something special. So it is X colon script equal sign instead of, it's not JSON, it's the special JSON which is used for description of JSON. So if we need to put something special, we make it with this recording x dot colon, and here is the keyword, and it is equal sign. So this way we can put into the JSON, description of JSON, some commands for X definitions. So principally it is very simple. All the values we can describe. We can describe typos. This is string, this is some year, months, form, and so on. And we usually put the occurrence. To values we can say occurrence directly here, because value can be or cannot be. It's just required or optional. And for the for other objects we can put it here. It's connected to the array. This array can be here in this map in this array can be here occur unlimited times. Now, what to do with JSON to XML? Here is Michael K, who described it a few years ago. It's very precise and very good algorithm, but it's not so useful for our purposes. It's not so readable and so on. So we used a little bit different algorithm, being inspired with Michael K's ideas. And it is much more complicated. JSON cannot be easily converted to XML. XML can be easily and precisely converted to JSON, but this is not so easy. Because JSON has maps, arrays, and primitive values. As the map can be empty, there is something new. What is the empty in XML? The array can be empty. What is this empty array? The map can have more items. So if it's map which has more names than one, if it's one, we can it transfer still to element. But if it's more, so we will need some special. Yeah, so I will be very, very fast. So I will show it. I'm slow. Yeah, you can see here the example where we need to put the special element if we want to transform it to XML. This is element with the namespace from X definitions, and this map is describing this map because it has two names, so we cannot simply create an element from that. So we must say it's map, and to the values we record the value of named values to the special attribute value if it's simple value. Moment. I have here somewhere an example, as it will be the last thing which. This is example how to how it, for instance, this example will be transformed to Tomáši, prosím. Jo, dobrý. Have we here? Is it connected to? No, it's not. forget it. No. Now let's say something about XON. The XON is a data model which is extending the JSON. It's exactly like JSON, but numbers can be described in detail. Number can be integer, can be byte, short, long, double, float, and so on. Or it can be also the date times, durations, and many other types of values. So XON is describing all data types which are supported by XML. So let's have this JSON example. Here is, and here is written a comment what we will expect it is. In JSON, it is just string. It is minus infinity, negative infinity, true. Now it is duration. Here it is a byte array, and so on. So this JSON we can transform to XON very simply. That in JSON we have comments, so we can write comments here, and with the red letters is specified what kind of value it is. If, for instance, there is not written S, then it is a number. It is an integer. If here is not this small f, it will be double, and so on. This in JSON must be string. Yeah? If you look back, now, similar way we are processing also Windows ini files, properties, comma-separated values. All these structures can be described by XDefinition, and we can use XDefinition as a general processor which is able any XML, any JSON, any create to XON, and from that we can create back XML, any of these formats. Or we can use directly XON to communicate with some other system. I'm very sorry, I am very slow and very old, so I will give floor to my friends for a while.
Hello, everybody. Is it working? Nope. Low battery.
Switch it off.
So we switch the microphone. It's a little faster.
Take.
Hello, everybody. I would like to thank the architect that he describes very briefly the XON. My name is Tomáš Šmíd, and I will show you a few and very fast practical examples of using XON. And the first example is how we can process the data from JSON and the XON. This example is about that we have two types of different input data. Meanwhile, we have only one description of the data model. It means we have one validation model. On this slide, here is JSON. So I think it's well known. It's composed from two records. Those records are structure equals. We can see that each of the records has 4 elements, and on the first line there is an array of those records. So this one is the JSON. Similarly, we can create same data in XON. There is very small differences, and especially as Václav mentioned, it's in the type. Everything else is the same. So, if we want to validate or somewhere else process those data, we can use, for example, this X definition. This X definition is quite different. We have presented here at XMLPrague many years ago for the XML purposes. This one is for XON, but we can see that we can process the JSON data and also the XON. The structure is really very similar to input data, so we can think that it's easily to read and use. Based on this very simple example, we can build our, let's say, more difficult real case scenario. We already know that we can use X definition XON to validate JSON. If we combine this new feature with stream data processing, which is already implemented in X definition, we will be also able to process huge or very large JSON data, which you can receive from your customer or whatever else in the repos, for example. So, the real case scenario is telecommunication. Imagine your company has a task that you have to process data containing information about devices in the network. Those data in JSON format, which is typical standard today, and you are receiving those reports for some period. Let's say it can be 1 day, 1 week, and it means it will contain thousands or even millions of records. So my question is, how would you like to process those data without loading whole file into your memory? And you don't want to spend like 10 of gigabytes of memory for processing these files. And the next question is, how you want to do that if you want to spend so much memory without your own data parser? Well, one of the possible answer is you can use the X definition. This is very simple example from one of the possible customer. We can see there is very simple record with few elements. In the real case, it's really huge or bigger. And this is only one of the record in the whole payload. We can imagine that there will be really millions. So we can use this X definition, which continues on the next slide, to describe the record. There is a continue, and also again we can see that it's very similar to input data. If we use this X definition with the rest of X definition technology stack, we can process the data by the streaming way, and it's free. So that's for the real case user scenario, how we can use X definition for cases if we need to process the JSON instead of XML data. The future development is like we are finding the ideas what we can do else now, because we already start to process a lot of type of input data. So the question is, what else? What's next? As now, we are focusing on accessibility. We want to open X definition to the world that other people can use it for free. As far as we know, the main interesting about this technology is especially the streaming data processing. People are coming and saying, hey, we have a problem with processing a huge data file, for example, 20, 30 gigabytes and more even. So that's the main reason why they are trying to use XDefinition. We open sourced this in 2018. Now we have a few other people who like that. And the next our step should be focus on platform independence. XDefinition has been for a long time developing as internal tool, and it's very hard linked to our platform, which is the Java. And this is quite a weakness of the system. So we would like to create a general standard which would be independent on the platform. It means that we should create the new, let's say, derived specification on the current specification of XDefinition. And this standard can be implemented in any platform. It can be one of our goals. The standard will be very similar to currently one, so we need to reuse the basic blocks of the XDefinition. So it means we need to data types, which can be, for example, extended by any programmer if you need for your internal uses, for example, internal data integration. Then you have a structure, so you need to somebody describe how the that input data can look like and what's the type of them. Then we use the events. So that's, of course, we have something like internal data processing in the XDefinition, and the events are internally triggered, like the lifecycle. And the last part is external methods. If you want to call your own code to some other logic to validation or any other operations, it just depends on you. And it should be everything for me, because we don't have so much more time. And thank you so much for your attention.
We have 1 or 2 minutes for question. Any question? Oh, thank you again. Thank you very much for the presentation. Next speaker will talk to us about